And now in this part of our course, we are in the lab where we have this system named cryostat. And with this system, we can reach very low temperatures, very useful for a lot of experiments in nanoelectronics, molecular electronics, and also for setting up systems for sensing. I introduce you this time Dr. Davide Dapra from Istituto Italiano di Tecnologia, the Italian Institute of Technology. He is the responsible of this instrument, this cryostat, and so Davide will show us how to use the cryostat, inserting inside the cryostat the chip with the gold wires, and what we will do today, it will do the same thing that we did in the last lecture, so we will try to create a nano gap inside the cryostat at a very well controlled temperature, at a low temperature, and in a very well controlled pressure. Of course, cryostat we will use it, and it is used in general in research, also for doing measurement at low temperature, where you have not only the controlled temperature and stable temperature, but to work at low temperature, your noise, the noise that arrives from outside, because you will see the cryostat is in a closed chamber, but also mainly because of the low temperatures, the thermal noise is very, very, very low. And so you can put out from the thermal noise and the other noises the signal that you want to detect. So let's pass now to show you which is and how is built the system. This is the most precious and important part of the instrument, where we have what is named the finger. In this finger, we will insert our chip, and here the system will create the low temperature, and as you can see here, we have small cables, wires, that will be used, and I will show you later, for interconnecting the chip, and you see, for exiting from the finger of the cryostat to the connectors, so it will be possible to connect the boards, the nanoboards that you already well know, for controlling the experiment. Here you have the controlling part of the system, where you can see we already prepared what we will do. So we will put the temperature not a so low value, because this system can reach a minimum temperature of 10 Kelvin degrees. We do not need to arrive today to that temperature, so it will be enough what we preset here, so 100 Kelvin degrees. Of course, with this control equipment, you can set up different parameters of the cryostat, but for us today, it's enough to know this, the temperature that we will reach in our experiment. This last part is the pump for creating the vacuum inside the finger. We will set up a vacuum pressure of 10 to -4 millibars. So now, with Davide, we will set up everything, and I will show you the different steps to set up the experiment. Okay, first of all, we start again from our chip. You remember this morning I showed you that here we have the chip with 8 probes with inside the wires in which we can create the gaps. Around we have a wire bonding to a PCB that is used as interconnection. And in this case, we have this piece of copper that it is used for putting out the heat, and so to have a possibility to put and to create the low temperature inside and on the surface of the chip. And Davide now will show you how to interconnect with these two wires. He will solve them on the pads of the PCB, so we will contact the wire inside the chip using these two cables. And Davide will place also this thermocouple, because it's important to have a measure of the temperature very close to the chip, because yes, you have a temperature of the finger, but from the finger to the top of the chip there are a lot of pieces, the copper, the PCB, and all the things. So it's important to put this thermocouple closest as possible to the chip, to have as much as possible the correct temperature that you have on the surface of the chip. So now I pass this to Davide, and he will do all the needed steps for inserting our chip inside the cryostat. So with this screw, you see, it's possible. We prepared this custom with all these pieces, so it's possible to screw it on the head of the finger. It's important to have as much as possible good contact between all the parts. In fact, I don't know if you have seen it, but we have a thin sheet of indium for increasing the thermal exchange between the finger and the copper and the rest. Now Davide is placing the thermocouple, and now he will solder the wires to the PCB board, that is the interconnection with the inside silicon chip with the the gold wires. Okay, the work is done. So now we can show you. Here you see the thermocouple placed here. It is not on the top of the chip, it's not possible, but it is as close as possible. And here we have the two soldered wires on the top of the PCB. Okay? And now the system is closed. Of course, moving parts usually happens that the things. Okay, the wire now is soldered, and we close the cryostat. Okay, now the system is closed, and so we are measuring the resistance between the two connectors that are connecting the wire inside. Now we can see that the resistance that now we are measuring of our wire on the chip, our gold wire, are 57 ohms. So we know that the contact was done correctly. As you see here, now, thank you, Davide, we have the two wires that from the board, the nano board, are interconnected to the cryostat. So, with the same system that we showed you in the last lecture, we will control the production of the nanogap inside the cryostat. I want to add that now we want to redo the same experiment that we did in the previous lecture, but you can imagine that if you want to, for example, measure, characterize other things, so maybe a nanogap with inside a molecule that you put previously, it's a perfect system, so you can cool down the system and do the measurement of your nanogap with the molecule inside. So now what we can do is to switch on the pump, and with this pump we have to wait a few minutes for reaching the 10 to minus 4 millibar vacuum system. After it, we will pass to start the cryostat system that will use, as you can see down, we have the part that is containing the liquid helium that is needed to cool down the temperature inside the finger of the cryostat. So now we can stop for a moment the recording, because now we switch on the pump, then we switch on the controlling system, and we have to wait half an hour for reaching the correct vacuum and the correct temperature, and so we will continue later when we will reach the correct experiment setup.